Hello students, in this video we will look at how to determine appropriate sample size for confidence intervals. How to find the correct n value. Let's take a look at our confidence intervals. We're going to be looking at this one. Sample mean plus or minus our z times our standard deviation over the square root of our sample size. Sometimes before we actually start our survey, so this is done before any type of data collection, research manager or someone in that group will specify a level of error. So they will specify our margin of error. I'm going to abbreviate that ME. So they'll specify our margin of error. We have to remember our margin of error is everything after the plus and minus sign. So our margin of error includes a Z value, includes standard deviation, and our sample size. Now if we want to have a smaller margin of error, how can we do that? Well, we could change our Z value. Our Z value is based on our level of confidence. If you want to have a smaller margin of error, what you would end up doing is decreasing your level of confidence, going from say 95% to 90%. That's how we could actually change or reduce the margin of error by decreasing our confidence interval. So we come margin of error is smaller, but we are less confident that our confidence interval is going to include that population parameter. So changing our Z value, not good. We could look at the standard deviation. That is a value given to us that's being calculated before. This is a calculation type value, so we really can't affect the or change the population standard deviation. It only leaves us with our sample size. Who controls our sample size? Well, the researcher does. So in order to have a smaller margin of error, the only thing we can do is change our sample size. And the only way to do that, if we want to have a smaller margin of error, is we increase our sample size. So let's take a look at how to actually set this up so we can determine the appropriate sample size before we start collecting data. So let's erase this. So once again, this is something we do before any type of data collection. We are trying to determine our sample size. So we need to know how many people to survey, how many houses to knock on, how many items to measure before we actually go out and measure them. So remember that our margin of error, write it in here, margin of error, ME, equals everything after the decimal place equals our Z value based on our confidence interval, population standard deviation divided by the square root of n. If we want to isolate n, basically we end up with this. And everything in there is squared. So to find the appropriate sample size for confidence interval process that involves the mean, so we're going to be given the population standard deviation. We specify what level of confidence we're looking at, and someone in the marketing research team tells us what the margin of error is going to be. So let's look at an example. This is from your course package. Large company likes to know the average time workers spend driving to work each day. The company wants to select a sample size that provides a 90% confidence with a margin of error of 2.3 hours. A previous study had a standard deviation of 13.5. How large should the sample size be? So this is a classic example of trying to determine how many people, how many workers we need to survey in order to collect sufficient data that gives us this margin of error 2.3 hours. So let's just erase that. One thing that we have to determine is, where does this value come from? Where does that come from? Now the question we're dealing with, it gives us a previous a value from a previous study. That's a great place for it to go, because remember, a standard deviation is something that we calculate after doing the survey, but we want to determine the sample size before. So our standard deviation either comes from a previous study, or it can come from a pilot study being a small version of the study that we're going to conduct. So we can give it out to 100 people beforehand, gather some preliminary data within that calculated standard deviation, which we could then use to determine how many surveys we need to do for the big study. Or basically we have to guess. So generally there is a previous study or a pilot study process that we can use to get at this answer. So let's erase this. So we're trying to determine the sample size. This is what we know. We know we're looking at a 90% confidence interval. We know that the margin of error that's specified to us, margin of error, equals 2.3 hours. The standard deviation is given to us from a previous study of 13.5 hours. So remember that a 90% confidence interval, that translates to a Z value of 1.64. So let's put this into our formula. 1.64 times our standard deviation divided by our margin of error, keeping in mind that everything in there is squared. So the appropriate sample size we would need would be 92.6. So we're going to basically round that up to 93. So if we survey 93 people, assuming that our standard deviation holds to be close to 13.5, we would have a margin of error of no more than 2.3 hours. The second type of question that we can do with this involves, second example, involves trying to determine the appropriate sample size based on a different set of data, different type. So a poll is to be conducted to predict the winner of the upcoming election. If it is desired that the margin of error is to be no greater than 3.5%, what is the appropriate sample size needed for a 95% confidence interval? So this question, we would eventually build a confidence interval for the proportion of people voting for a certain party. So we want to develop a margin of error that would, or develop a confidence interval that gives us a certain level of, certain margin of error. So our confidence interval formula for the proportion, just as a reminder, is this. Keeping in mind that everything over here, this is our margin of error. So it's the same process. We can calculate, or we can write the margin of error as being just like that. We'll change colors here. We can rearrange that formula to isolate n, keeping in mind that we have to square everything to get rid of the square root of p times 1 minus p divided by n. So what we're left with is n equals z squared times p times 1 minus p divided by our margin of error squared. Not everything on the right side is squared, just the z value and the margin of error value is squared. The question becomes, what value do we use for p? Keeping in mind that we are trying to determine how many items to survey, how many people we need to actually survey in this poll. So we don't know the proportion of people that will vote for one party or the other. So this p-value can come from a previous study, it can come from a pilot study. We can take a little guess, but this is the one I'm going to hold everyone to. Let's choose a different color than yellow. This is the one I'm going to use. Generally, if a previous study or pilot study is not known to us, what we want to use is a p-value of 0.5. A 0.5 value for p will in essence maximize our sample size. Any other value of 0.5 will come back with a reduced sample size value. So let's take a look at how this would play out in a question. Let's erase this. Let's go back to our question. Basically, we're given three numbers: the margin of error and the confidence interval. So we know that the confidence interval is 95%. Margin of error is 3.5%. If the confidence interval is 95%, we know that Z equals 1.96. So our sample size, our appropriate sample size, is going to be 1.96 squared divided by our margin of error as a decimal form, 0.035 squared. But we don't know, nothing in the question tells us what value of p to use. There's no previous study mentioned, there's no pilot study. We're not going to guess. So if those values aren't given to you, we use a value of 0.5 for p, and then 1 minus 0.5 for p as well. Keeping in mind, as I said, that using that value 0.5 maximizes our sample size. And it's always better to survey too many than after you've collected your data, you've calculated it, and you realize that you needed 100 or 200 more people in your survey. It's always better to have a little bit more. So if we carry out this calculation, we get a sample size of 784.